Aaron Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Hey everyone, Meteorologist Aaron Tuttle back with you again. It is Thursday, a few minutes after noon. Yes, I am late to my own party. I do understand that. A lot going on this morning, as always. So, hey, life happens, right? So thanks for joining me. We're going to talk about the severe weather threat for today to see if it has increased, changed, shifted directions, all that kind of stuff. We'll talk about the threats, where they may be, and when it'll start, all that kind of stuff. So make sure you like and share the video, tap the bell to get notified, like the page you're on, whether it's YouTube, Facebook, Twitter, X, or, of course, Rumble. And I'll put in the broadcast section in the chat for Rumble, where you can also join the Facebook weather broadcast channel, and also options there for you to support if you'd like to do so. And same thing for you guys out there on X World, same idea. And of course, Facebook knows the deal. This is really all created because Facebook just wouldn't notify you whenever I went live, because they changed the algorithm so many times, because there's so many pages you follow, right, and people. So it never knows what you want, so this is a workaround for all that. So make sure you join one of those options. That way you never miss a broadcast, especially when we're talking about severe weather, tornadoes, all that kind of stuff, right? All right, so with that housekeeping out of the way, let's get on with the details, shall we? So currently, if you haven't noticed, humidity has returned. It's pretty gross out there. You see a lot of low clouds. We've got a lot of low-level moisture that has returned in the form of those deep stratus decks that do come in across Oklahoma, which obscures the sun. There are some breaks in those clouds that are coming in from the south. We're going to show you that here as well. Now, as far as any storms go, currently we don't have anything in Oklahoma for the time being. Things are fairly quiet across our region, but that'll be changing here in the next few hours. Here's a look at the water vapor loop. And it shows you what we really have is a little bit of a trough coming in through here. And this is going to create lift in the atmosphere out ahead of it as it swifts east. It's already kind of have a little bit of effect on the leading edge of it here. And one tried to go around here. So there are already beginning stages of some lift in the atmosphere from that. But that'll be what kind of helps to get storms to kick off here for this afternoon. If you do look at the satellite viewpoint, you can see the low-level juice coming in all the way to Kansas, now tipping into Nebraska. This is that stratus deck I was talking about. But you can also see subsidence has caused some break in that stratus. Subsidence is sinking air from the thunderstorms down here, south of it. That sinking air moves to the north, disperses the cloud deck, lets the sunshine in, which, believe it or not, actually destabilizes things even more. And that little area will work its way to the north here into Oklahoma this afternoon to help us to continue to destabilize. If you do look at the threat today from the National Weather Service Storm Prediction Center, this is our slight risk here. So they have tapered it back a little bit to basically kind of eliminate the northeastern quadrant of the state, otherwise keep the body of Oklahoma still in the slight risk, and also all of north and central Texas too. If you look at the tornado threat, they've also streamlined that from pretty much over the entire state to eliminating northeast Oklahoma, and then kind of keeping it pretty much around the Oklahoma City metro area, back into this area. Honestly, though, again, the green is also an area for tornadoes. In other words, they can be within that zone, but they can also happen outside of the zone. These are probabilities. In other words, how, what is your, chance of seeing a tornado within 25 miles of an area is how this is broken down. So it's all statistics. Try to put numbers to your threat level. Bottom line is, where you have the higher the number, obviously that's where the focus is for more of those severe storms. That can't produce that. If you look at the close-up view here from the National Weather Service, this is where they have the low threat for tornado potential. They have it very low once you get east of I-35, is because the timing, as in the storms will be after dark and they'll start to weaken little by little. But they do have, of course, the entire area in yellow for slight, up to baseball-size hail, 80-mile-per-hour winds. And we looked at last night the sounding data. Softball-size hail was not out of the question. Neither would be a wind gust in excess of 80, because this time of the year that can happen. The profile gets really loaded with some nasty ingredients. Here's a look at the northeastern Oklahoma view. So slight to a marginal risk across the rest of the part of the state. All right, so if we look at the AI algorithms, this is where they favor the tornado threat. And they stretch all the way up here into South Dakota and just a tad bit in North Dakota. Again, back here into central Texas and on off to the east. So a much larger area from the Storm Prediction Center. But needless to say, these are all areas where you could get a tornadic storm in that region. Let's take a look here at the analogs, which does favor the sweet spot, pretty much right along the I-35 corridor and points west and then up north from Oklahoma into Kansas and into southern Nebraska. In other words, similar systems with similar ingredients. This is the outcome, is what it's trying to tell you, and it sounds a probability. If you look at another AI model, it also favors the western half of Oklahoma and kind of gets a little break, but it also likes the Dallas-Fort Worth area and points south and east on I-20 toward Tyler. And then has a secondary area up here, or third area, I should say, across most of Nebraska, and then a little tiny little zone up here, like I said, North Dakota and South Dakota. All right, so that's a large area that we can see some severe weather with tornadoes being produced. In the upper levels of the atmosphere, we do have a storm system that's zipping this direction here. So we're on the kind of what we call a tail end flow. This is basically a zonal / southwesterly flow aloft. You get these little colors, which indicates little ripples of energy, and they don't always get picked up by the models well, especially when they come in from this area because they're not sampled by any soundings until they get over Mexico. And usually by then it's too little too late. There's not enough soundings down here anyway to really help us out. So these are always little sneak attack events a lot of times when you get this time of year from that pattern. Here's a look at the NAM model, which does indicate where the lift is going to be occurring later this afternoon and evening in these little red areas. So the dry line lights up, of course. This little area here in northwest Texas, also Dallas-Fort Worth, some convective feedbacks. It thinks that there'll already be some storms in that region. Same thing here on the significant tornado parameter. This little lack of data indicates where it already has storms forming by 4 and 5 o'clock. Now, where you don't see those storms forming, you do get some pretty high numbers on these values. So for example, let's just take one here in Oklahoma, kind of give you an idea of kind of the worst case scenario as far as what the atmosphere holds for these particular thunderstorms should they tap into the environment. Cape values up around 5,000 joules per kilogram. Very low LCLs, in other words, that's the cloud base where you can lift up and almost touch the sky. So when you have an LCL very down low, you can literally get on your roof and touch the bottom of the cloud, it seems. That's how low they are. But that also is favorable for tornadogenesis. And same thing with these winds. Look how these winds turn from southeasterly direction at the surface to southwesterly direction very quickly in the first 1,000 meters off the ground. That's a lot of spinning in the atmosphere for storms to take advantage of. Again, hail size is well over baseball up to probably even grapefruit at times is a possibility. Any tornado that would develop in this environment should be a rather strong tornado as far as potential is concerned. So big hail, big wind damage rating at 1.5. So again, over 80 mile per hour winds not out of the question, and that's just that one little spot, which is like it's called like cherry picking, right? You want to pick the most ingredients you can find just to see what your upper limit is on the severe potential. And this is also kind of scattered in and around into North Texas as well, so not much difference down there. So if you get a storm, it's going to be big is basically the bottom line. Here's a look at the 5 o'clock time frame. We can look at the 3 kilometer NAM and also the HER, and it does show you where a lot of these Cape values are in excess of 5,000 joules. Remember, that's just a measure of potential energy in the atmosphere that turns into kinetic energy. In other words, it's something that the storm can realize and then convert and then go big from nothing to something really fast. And with all these little triangles you see on the map, these are the wind barbs from the surface to the mid levels to upper levels. And so that just basically means the bigger the spread here, the bigger the triangle that you see, means the greater the wind directional shear. So in other words, this vector here to this vector here, right? You got to do some old school geometry, see what this angle is. Well, that's greater than 90 degrees. If it was 90 degrees, it'd be cut off here, right? Well, obviously 90 plus about another 30. So that's about 120 degrees of shear, which is directional shear, which is much supportive for tornadoes. All right, same thing for the HER. Same idea. We have a lot of good shear and Cape values across the state. So really, the only difference is, where the focus is for those to develop, and then where's the cap. Well, if you look here, because there's a lack of numbers in this region, the HER seems to think that storms will fire already in southern Oklahoma. 3 kilometer NAM, as we talked about earlier, also likes this area, which means it thinks storms have already fired. So look at their output here in a minute, just kind of show you the difference. If you do look at the dew point values, we're up into the mid to upper 70s. Up here in northern Oklahoma, it drops to the lower 70s, and then back here in the far northwest Oklahoma into the 60s as that moisture is still working in by 4 o'clock. So the better moisture is confined across the I-40 corridor and points south for those storms to work with. If we take a look at the tech model, We'll see how it does. I haven't looked at this one yet. It does have some storms there in northwestern Texas by 4 o'clock, and coming off this Texas state line in western Oklahoma also. Those will all have little helicity tracks with them for large hail damaging wind, potential tornadoes. So there's the 6 o'clock hour. Look at that, Dallas-Fort Worth. Look at all those storms in and around your area. Points to the west, all of those with helicity tracks. That's a big cluster of potentially tornadic thunderstorms. There's that one storm that makes its way here into central Oklahoma, then disappears, basically falls apart by 8 o'clock. But until then, it looked pretty strong, at least on that model data. Here's a look at 3 kilometer NAM. We'll see what it's got up its sleeve. Looks like it continues its trend from last night, which is developing storms by 3 o'clock here across southern Oklahoma along the state line. The cluster expands and moves into central Oklahoma by around the 6 o'clock hour, and it also fires off storms on the dry line. Again, a lot of helicity tracks with these, which means any of these could have all 3 threats. Now, it does by 7 o'clock. It looks like it struggles to keep those storms going in central Oklahoma, and then it keeps those ones out west coming in from the west, and then starting to fall apart as well as they get closer to the I-35 corridor. So this model then, just based off of what you see here, tells me that it thinks the cap is going to be pretty strong today, and that's going to give those storms a problem at staying rooted and continuing their development. Now, as we head to Friday morning, another cold front comes in, and that triggers at least a few showers, maybe some elevated thunderstorms. Then by the afternoon, this model doesn't do too much with it, but other models by 6, 7 o'clock do produce a few severe storms in this region for far southeastern Oklahoma. So that's another thing to kind of keep an eye on. Move this over to the left a little bit so you can see it. All right, let's go into, now I believe it goes into Saturday afternoon. It doesn't do much, but just to let you know, there is a threat for severe weather along this corridor, especially for late Saturday afternoon and evening for more storms to fire along the dry line and then move into eastern Oklahoma. And then, of course, some of those will be after dark, heading into far eastern Oklahoma as well. So we'll see what happens on Saturday. Right now, we're just going to focus on today. Let's go to the HRRR, and as a little different look, it also tries to produce a few showers and storms here around lunchtime. That's not happening. It doesn't really do much with them anyway. It falls apart. Now, it does produce just a pop-up random supercell. Like I say, at Lawton at 5 o'clock, and then boom, it's got that one storm. Has something there in western Oklahoma. There's one in Kansas. Now, it moves this one right in Oklahoma City. All right, at 7 o'clock. Now, again, this model won't be that perfect, for one. Number two, it's got way too much dry air in here, and that is a notorious bias that this model contains, so we'll have to assume there's better moisture. So we'll assume better moisture, which means a lower cloud base. We can keep it sheer if we want, that's fine. And so what that means is it's a tornadic storm, and it's pretty strong as it moves into the metro. Now, as I told you before, no model knows the exact placement of these storms. It's a general idea, general area, so heads up. Meanwhile, it also forms another storm out here on the dry line, but this model is actually fairly quiet. There we go, it's 8 o'clock, 9 o'clock, 10, and there's 11, and poof, bambooses. And then we got the stuff down here that crawls from North Texas into southeastern Oklahoma around the midnight hour, and those move out. So there's two different models, two completely different looks to the data. And we talked about this last night, about how all these models have just a slightly different look to them. This is the RRFS, which is an experimental replacement of the HRRR, which unfortunately, I hate to say it, but it really stinks. However, it's loving supercells today, and it just wants to produce them everywhere, here across this little section of the state, even some down here into southern and southwestern Arkansas. Now, this model rarely pans out. I'm just going to let you know that now, but that's just the signal, which, believe it or not, that signal isn't that far-fetched or much different overall collectively. So it might actually be like a broken clock and be right once, but for different reasons. We'll look at the... we'll go with this one, the Nestle. So these impasse models are also experimental. They're new. They've been trying them out this year, and they've actually been doing pretty good. Now, this one has a lot more activity along the dry line at 4 and 5 o'clock. Scattered stuff elsewhere over central Oklahoma. And you got to keep in mind, any of these storms that do develop just out in this little warm sector area, as we call it, you still have to keep an eye on them, as they could still be tornadic. Let's see, let's go to 6 o'clock, 7 o'clock, 8 o'clock. So they do move through the I-35 corridor, still holding together down around the Lawton area, on up into northern Oklahoma after 8 o'clock. And then there's 9, 10, does weaken as it moves into Tulsa. But remember, a lot of times when these storms start to weaken and they get in this configuration, they kind of drop their load. And by dropping their load, not only their hail, but also their wind. So even though you guys are kind of on the out of the slight risk into the marginal, like I said, as long as you're in around near the area, you can be under the gun sometimes depending on how things evolve. Okay, and then we'll take a look at one more. We'll do this one. These basically are cousins of each other. They have just slightly different configurations in the data. And let's see. Nope, that's the one I looked at. Sorry, let's go to the other one. This guy here. All right, this one. So there's some stuff that tries to bubble up here at 2 o'clock in southern and southwest Oklahoma. And that's as early as the show could start. We have to keep an eye on this down here. This is where that clearing slot is, where the heat gets in there. So it could happen. And if they do so, they could work their way to the north towards central Oklahoma early, while these storms start to develop later in the afternoon by 4 and 5 o'clock out here in western Oklahoma. All right, then those move east at 6 and 7, coming to the metro here between 7 and 8 o'clock. Those have a helicity track with them. Both of these do, which again could mean tornadic. All right, so then that moves east of I-35 through the rest of the evening, continues into southeast Oklahoma. They hold their own, right? And this actually has a pretty good look of a line echo wave pattern. So in other words, it probably has a little mesovortex built inside of it, and like a bookend vortex, which usually means damaging wind within that line, a little small section of it. Let's see here. And then for Friday, this model likes to fire off more of those storms like I talked about in far southeast Oklahoma and in North Texas. So Dallas might actually get 2 rounds of potentially tornadic storms, one today and one tomorrow because of that front. All right, and that's pretty much it for that one. Here's a look at rainfall amounts. The models aren't doing too good as far as how many storms are going to be there and the placement. So what you're going to do to take away from this is if you don't get much of rain or storm, you're in this little light green area, which is rainfall amounts, a couple of tenths. And that's an upper end. I mean, in other words, you might not even get anything at all. Whereas if you get underneath these heavy thunderstorms, like a signal here, you can pick up a quick 1, 2, maybe even 3 inches of rain. If you get like a line of storms, like some of those models indicate, you can pick up a quick 2 or 3, maybe even up to 4 inches of rain. Some of the model data we looked at last night, I think, had 5 or 6, especially down here in southeast Oklahoma. So you can get some big flash flooding events on a localized level in short time scales. Here's a look at temperatures. Now today, we're going to be in the 80s, and then tomorrow we'll also be into the 80s, but tomorrow's 80s will be a bit different than today. Today is going to be the humid 80s, tomorrow much nicer here in Oklahoma City. Points north and west. Still muggy though in southeastern Oklahoma, so the front won't quite clear you by then. And then over the weekend, gross, it is what it is. It's low 90s. And look at this dew point Sunday morning, 69. Ugh, if you get a dew point in the morning hours, that's right around 70 or low 70s. Welcome to Houston. Welcome to what happens down there. And if you ever lived down there or visited, you know how humid it is along the coast of Texas. Is basically we're bringing that humidity, that moisture, right up here in Oklahoma. Otherwise, still looks pretty decent, at least better for Memorial Day. But otherwise, after that, pretty much standard stuff that we have to look at. So that was everything. I had to kind of run through a lot of stuff in a nutshell. But bottom line is, any storm that does get going today will have the potential for hail. I just made hail and wind a new word. Hail, wind, and tornadoes. Large hail at that, so baseball size, or maybe in a couple stones higher than that. Some of the data we looked at last night have to have grapefruit size for the analog data comparisons. And then we have the winds, excess of 80 miles per hour. Now, good news is on these events, not everybody gets that kind of wind. It's just what's capable in the atmosphere from these thunderstorms, and those usually come in pockets, like hit and miss. And if they're supercells, they're confined to the RFD section, which is the rear flank downdraft part of it. Or if they try to line out and do some configurations, or maybe they're gusting out, where they're turning into a little bit of a different configuration, which allows them to be more of a straight line wind making event, like a squall line or something. That's when you kind of realize those little areas of wind. Otherwise, it's not like everybody gets 80 mile per hour wind. So just keep in mind, it's still storm related. And those storms, if isolated in supercellular, are much smaller. They're like the size of a county typically, but only, say within that entire county, only one part of the county would experience that kind of wind. The rest would get the hail, in pockets of just regular standard thunderstorm winds, like up around 50, 58, something like that. But for the really damaging wind, it's closer to where there would be the hook echo, like I said, where the RFD is, or where the potential tornado would be. Let's see. So pretty much anywhere is fair game. The theta E axis is pretty much on top of us, which kind of focuses slight convergence with instability and moisture. So that could just kind of pop stuff up where you get the cap in little weak areas that kind of collide, commingle with that. Let's see, and then you have the dry line out in western Oklahoma, which fires stuff off usually this time of the year. So that's what it is. It's a warm sector event. We're going to have a pop-up supercell storms here and there. Activity could start as early as about 2 o'clock along the Red River, maybe in northwest Texas, in the far southern southwestern Oklahoma. And then every hour after that, the probability does increase and go up from that area, pretty much into central Oklahoma. And anywhere is still fair game for these thunderstorms to bubble up. It could be north, could be south, could be a little east, and then definitely west around 3 and 4 o'clock along the dry line, and then those will move eastward as well. So we'll track all those. So I do expect some of these to be tornadic. Therefore, I'll be broadcasting live throughout the afternoon and evening to make sure you're safe from that. Make sure you get my weather app. It's free, AT's Weather to Go. It's on Apple and Google Play. You can download that now. You can plug in your location of all your family members, your friends, your different locations, from business to lake house to you name it. It'll alert you if you have anything dangerous coming your way for those. We can keep tabs on everybody. Let me see what else. I think I always forget something. But it is what it is. And I got to go because my lunchtime's coming to an end. But I appreciate you guys tuning in. Again, on Facebook, YouTube, and Rumble, and Twitter X. Make sure you tap the bell, / join the page, / click to get notifications, all that stuff, that we don't miss anything when we do go live later on this afternoon and this evening. Be safe, everybody. We'll talk again soon. Again, if you're in Oklahoma City, storms could start as early as 3 to 4 o'clock, but every hour after that, again, the window opens up. You guys in Tulsa will be later, probably into the evening hours before your threat arrives. But just in case something pops up, use my weather app. It'll track radar for you on it. It'll give you time of arrival, storm track arrows, all that kind of stuff. You can do your own radar analysis on the fly. So, all right, we'll talk again soon. You guys be good for the rest of the afternoon. Sorry I couldn't talk to get your questions or read what you had to say because there's too much to do and I got to get. But I do appreciate you timing in, talking, chatting, telling where you're from, all that kind of stuff, and building the community. So it's really good. All right, I'm out. You guys be good. Talk later. Bye.